Hello friends. So last time you have seen the tangent approximation or your linear approximation. So when the given approximation is good and all this thing is seen, so please remember that we have seen for your single independent variable means y is a function of your f of x, and we have seen this delta y is equal to your dy. Okay, so for this case we have seen, that's why we have used the word is tangent line. Now if your function z and which is a function of suppose x of y, so here we have two independent variable, this is x and your y, and the corresponding change in your x and y, that is decide your value of your z. So that we want to find out over here. So here the two things will be variables. Suppose I want to find out the total. So my aim is what? This is concept of your total differential or differentiation. Okay. So due to these two independent variable, what will be the change in your z? So total change in your dy for a single variable. So this is nothing but dy is nothing but what? Tangent to the line. Now this is depend on single variable. This is depend on two variable. Now this is your surface. Okay, surface. So f is a function of your x and y, that will be decide your one surface, and you have to give the tangent to that particular surface. So basically your dz is nothing but your dabba f by dabba x. Why you use the word dabba by dabba x? Because this is partial differentiation, because it will depend upon two variable into dx plus dabba f by dabba y into your dy. So here this is the partial differentiation of this particular function with respect to the x. Okay, and delta x we have changed it with dx. Partial differentiation f with respect to the y and dy. So this dz is represent a total differential. Okay, so this dz is represented total. So what is the physical meaning? Physical meaning of your dz in terms of geometry, that we'll see over here. Okay, so this is my curve PQRS. Listen carefully. PQRS is my surface, because this is represent what? Your surface. Okay, so basically this is three-dimensional picture. PQRS is a surface. Now you have to give the tangent to the surface. Tangent to the surface. So here tangent to the line. Okay, so in this case one surface PQRS is my surface. So this is my surface. Okay, this is, and you have given the tangent to that particular surface at a point P is what? PABC. Tangent to the surface is what? At a point P, PABC. And your PDEF is represent a horizontal surface. Horizontal surface. So we'll take example. Suppose we'll not clear over here, so I will show you here. This is my plane surface, which PDEF. Now this is my curve plane. Okay, this is one particular plane is there, and that is nothing but PQRS. Okay, so this is your plane PQR and S. Now I want to give a tangent to the surface. So this is my tangent. This plane is indicate whatever the plane I am showing here. Okay, 1 minute. Tangent. Okay, so this is surface, it is just like surface, and plane, don't consider plane as one dimensional, this is two dimensional, tangent to that particular point P. So what is the value of dz? Dz is along this particular direction, z direction, because one side is your x, one side is your y. So suppose I will consider this is my x and this is my y, suppose. So that part will cover over here. So in this case, this is what? This is your surface, BC is your tangent, and this is your horizontal surface. Okay. So now along this particular direction, suppose y is constant. Here is what? This is y is constant. So suppose the change in f with respect to the x at that time y is constant, that I want to prove here. Okay. So what I'll do? I will do a simple case. So now my surface is what? At y constant. Okay. So this is PF is your dx. This is your dx, and the surface is which one? PSCF. PSCF is the surface where your y is constant. So y is constant means change is taken place in that function is what? df by dy into your dx. So what will be the change? So this is your graph, tangent you are taken just like this one. So and suppose y is constant over here. Okay. So only the x is changing with respect to that function. So we can find out that particular case over here. Okay. So this is nothing but what? PS is my curve. PS is my curve because y is constant, and you have given the PS is tangent to that particular surface. Okay. PS is your tangent, this is your curve. Please remember this is your 2D curve. Okay, because y is your constant. So you are given the tangent to that particular curve of intersection. So what will be the change? Change is nothing but C into F. Okay, with respect to x. So that is nothing but delta F by delta x into your dx. Okay, so this is nothing but your CF value. Now suppose we want to consider what? This is the change. Okay. Now suppose this is which plane I have to consider? This is x is equal to suppose constant, because it is function of two variables. Z is a function of your x and y. Initially we have considered y. So which surface I want to consider over here? I will consider this PQAD. Okay, so PQAD surface. Okay, and here this is your dy, means AD value. This is also dy, AD value. This is dy, this is dx, this is also dx. So here we have considered initially your y is constant. Now here x is constant. X is constant means the change is taken place along your y. So your function is varies. So curve is what? PQ is your curve. PA is indicate your tangent to that particular curve. Okay. And what will be the change in that function particular in y? So this is nothing but the delta F by delta y into your dy. Yes. So that is nothing but, now we want to find out the total change. So how we can find out? So in graphical way, so this is, I will draw a parallel this much distance. Okay, sorry, this much from this is your horizontal plane, this one. So CF is equal to your, suppose I will represent over here, so that is my G point, suppose. Okay, so this distance is nothing but dabba f by dabba x into your dx. Now the change in y, that is your here. Okay, so this is represent what? Your dabba f by dabba y into your dy. So that point over here, suppose. Okay, because PABS is your tangent C. PABC is your tangent to that particular surface. So due to the x, the distance is G into E, and due to, because we have find out the parallel case. So what will be that change? Sorry, it will be here. This is your parallel. This AD is equal to your this distance. Okay, so you will get this is dabba f by dabba y into your dy. So change, because your z axis is vertical one, Z is, so whatever the total change in z, so due to the x component, dabba f by dabba x is this much, and dabba f by dabba y into dy is this much component. So AD is belong to y, CF is belong to this one, and you can find out the dz. So this dz is nothing but dabba f by dabba x into your dx plus dabba f by dabba y into your dy. Now dy is good approximation, dz is good approximation to your delta z. So you can do in a previous, we have seen, this is your tangent surface approximation you have to consider, tangent approximation or linear approximation, and using that you can see. So this material I have already provided, you just go through it and you will get what I am to say, the physical. So basically this dz is represent a total differentiation of that particular plane. So along your x and y is y. So this physical significance we have seen. Now we'll see actual in terms of your book. Okay, so that is nothing but what? Suppose this is f is a function of your x and y. Okay, now the x it changes to your x plus delta x and y, because these are the two independent variables. So y it changes, so obviously f will be changes your f to your delta f. Okay, so this is nothing but what? F plus delta f, which is nothing but this is f of x plus your delta x and y plus delta y, because you are taken. So this is df I can consider, which is your f of x plus your delta x comma y plus delta y. Just I will take f over here and putting the value of, so this is minus f of x1. Now we will add one term and subtract one term. So this is nothing but f of x plus your delta x, y plus your delta y, minus, suppose we want to keep y is constant, so we can consider only change in x, so x, y plus delta y, so plus f of this term, add and subtract f of this term minus original term over here. So it is cancelled to each other and you will get original step. Then this is a change in x. Here x is constant, change in your y. Okay, so we want to change in x, so we'll divide and multiply with delta x, suppose here. Okay, so f of x, and we'll take limit because we want to at delta x tends to 0, y, So we'll do, this is delta x, divide and multiply with this one, plus this is f of x y plus your delta y minus your f of x y divided by delta y and into delta y. Okay, so this get cancelled, this get, and you will get original. Now this is nothing but what? Delta x and delta y are independent variable and their value is smaller and smaller. So then this is a good approximation. So for that purpose, what we have to do? We have to take limit of ohm. Delta x tends to a 0. This is in one bracket. Okay, and limit delta y tends to 0. This is in another bracket. This is change in what? Partial differentiation with respect to the x. X change, na? So f of x plus delta x, comma y plus delta y minus f of x plus delta y in this one. Change. So this is, we can write according to the definition, delta f by delta x. Which term is constant? Y. So we can write y is constant, and this value we can write, this is delta x is equal to your dx, and this is dy is equal to your this one. This is for good approximation you can write. Okay, just we have defined this term for independent case. In case of 2D function also we have defined this one. So this is your dx, okay, plus delta f by delta y times x into your dy. Okay, so this is one term, this is another term, and in case of your good approximation, then we can just see this is dz, you can replace with your dz. So this is your dz. So dz is nothing but a function of sorry, not dz, here we have taken f. So this delta f is equal to your df. So we can write down this is. So f is a function of two variables. So you can verify this is x comma y. So you can df is equal to delta f by delta x into y dx plus delta into this one. Okay. So the df is represent a total change in f due to the independent variable x and independent variable y. The partial differentiation of this particular function with respect to the x and with respect to the y, and when both are add up, you will get a total change in f due to x and y. Suppose your function is, this is f of x, y, z and so on. So same thing plus delta f by delta z into dz. Suppose w is there, delta f by delta w into your dw. So this is about your total differentiation. So many time we'll get question just like find out your df values and all this thing. So due to that one, so this is your 3D function, okay, 3-dimensional. So if you are taken f is a function of small thing, then you have to consider it's a 2-dimensional case. So this is about your total differentiation.